light is captured by that transistor. So it detects in which direction it is moving and at what rate it is moving. Right? So let me explain you how this is. So actually there are two LEDs. So if this is the disk, so one is at this position and one is at this position. So it's not completely visible, it's half visible. So imagine this moves in clockwise direction, a bit in clockwise direction. So this will hide. I mean, it's initially like this hides. Right? I mean, is it visible?
No.
Cool. So this moves. So it's still visible and this one hides behind it. So the first case is when you move it clockwise. Let's call it LED 1. Let's call it LED 2. Cool. So LED 1. So whenever it moves from light to dark, it's like this initially, move it clockwise. Right? When you move it, it's still visible a bit. It's still visible, but it goes from light to dark. It was half visible. But little movement moves it into dark. So this is still good. LED above one. And this moves from light to dark. Second case is if I move it anti-clock. So this is again at the same position. This goes into dark. This was half visible again. This goes into dark and this is also in dark. So in this case it moves again from light to dark and it's not visible. So it's like a two variable equation. I mean, you have to eliminate one case. If you have 2x plus 3y and 5x plus 2y, so then you have to eliminate y to get x. So to measure something, I mean, to find one quantity, you have to keep something constant. So you measure. If it moves from light to dark and it's still going, that means it's moving clockwise. And if it's from light to dark and it's not going, then it is anti-clockwise. That is how using this it detects the direction. And of course the rate of movement is also detected. Of course there are a lot of slits in this, and the portion of the transistor on which the light is falling also has a slit. So the complete light is not entering the transistor, only a part of that light. So that's how the direction is detected. In case of optical mouses, there is a LED and there is a small camera inside. So when you move it, what happens is it captures, the camera captures a lot of images from the reflected light. So from the reflected light, in 1 second around millions of images are captured. It works at MIPS. And then there is a DSP processor inside a mouse that is dedicated for comparing images. And it compares those images and checks what is the difference between the last image and the current image. So for example, if we divide it into squares and something like this, and the next time the image that you got has only this, when it's something like this, then of course there is a difference. It's just analogy, it's not really like that. So the DSP processor's job is to find the difference between this, and then find out, okay, this is how the mouse is moving. That's the job of optical mouse. And then in market you have laser mouse as well. Now the difference between laser and optical mouses is that in optical mouse you have a LED and in laser mouse you have a laser. Cool. So that's how the movement of mouse is detected. Again, it's very complex. So now, before we go into the details of how these mouse gets to know, okay, this is how it's moving, it needs to tell it to the processor, right? We will go into the details of that USB cable as well, but let me first tell you how mouse communicates with the processor. So one way is that, like for example, I'm the processor, so I'll go and keep on check. Mouse will be having a resistor, in which it will put some value, for example 3. This is for left click, right click and middle click. This is a very simple example. So it will, when 1 is entered by mouse and processor comes and check, it gets to know, okay, the mouse left click is pressed. Similarly, if it finds 1 here as well, then it will say, okay, here as well 1 is pressed. But you know, this is, if processor does this job of going and polling the mouse resistor every time, this is very inefficient. So what happens is mouse tells the processor, there is a dedicated pin on the processor, and mouse tells the processor, okay, I have got an interrupt for you. So I have a slide for you. So mouse tells the processor, okay, look, there is an interrupt for you. That's called as INT. Okay, so mouse tells the processor, there is an interrupt for you. If processor is doing some job, it will tell the mouse, okay, let me finish the current work that I am doing. Current instruction. Okay, it will tell the mouse that I am doing some work, I will get back to you later. That's called as interrupt acknowledgement. So the processor knows that mouse has something to give to me, but I am doing the job, so I will give it back to the mouse later. Then when it finishes the work, it tells, okay, put the interrupt number on the data bus. So the mouse will put this information on the data bus and tell the processor that here is the interrupt number. See, there are a lot of devices connected to your processor, like you have keyboard, mouse, printer, and everything works with these interrupts. An interrupt goes to processor and these actions happen. So for every such device, we have a unique number which is known as interrupt number. We will get into the details of this as well. So processor identifies if it gets, for example, interrupt number 1. So it will say this is for mouse. So mouse is sending me interrupt. Interrupt number 2. Then this is for keyboard. And so every device needs to give the right interrupt information to the processor. How this is, we will go into the details of this as well. So this is how mouse is giving information to the processor.
Okay, so what Anirudh told is about how mouse can communicate with a processor using interrupt based system. Okay, so the thing is, when processor is interrupted, then processor has to leave his job, complete the current job, leave that job and serve the interrupt. So processor will have to stop his current work, have to read explicitly the XY coordinates, which button is pressed, and then resume again his job. And you know how cursor is moving. It is a real-time operation. So it is not very efficient way to implement this system for mouse. So what people thought for implementing interface of mouse to actual your system is to develop such kind of buses which can actually communicate with the mouse without interrupting the processor. So how that job is done? So in earlier